Ever pondered about the edge of the universe? Where does it end, or does it even have an end? This is a question that has fascinated humanity for centuries. The answer lies in the concept of the observable universe. You see, we exist in a kind of cosmic bubble, dictated by the speed of light. Let's break that down a little. Light, as you may know, has a finite speed. It travels at approximately 186,000 miles per second. This means that when we look at the stars, we're actually seeing them as they were when their light left them, which could be millions or even billions of years ago. Essentially, looking out into space is like looking back in time. This concept gives rise to what we call the Hubble bubble. Named after the astronomer Edwin Hubble, this is the sphere around us from which we can receive light. It's like a cosmic horizon, beyond which we can't see. Anything that exists beyond this boundary is, for all practical purposes, invisible to us. Now you might be wondering, why can't we see beyond this bubble? Well, the universe is around 13.8 billion years old, so the farthest light we can see is the light that has had the time to reach us since the universe's birth. Anything further away than that 13.8 billion light years is currently beyond our sight. This creates a kind of cosmic speed limit. Even though light travels incredibly fast, the universe is incredibly vast, so the light from very distant objects hasn't had the time to reach us yet, and because of this, our view of the universe is limited to what's inside our cosmic bubble. So, we are in a cosmic bubble, limited by the speed of light. But is this the ultimate boundary? Well, hold on to your seat, because as we'll discover, the universe has a few more surprises in store. Just when you thought we had a limit, the universe throws a curveball. It's expanding. Yes, you heard that right. Cosmic expansion isn't just a theory, it's an accelerating reality. Picture this, you're baking raisin bread. As the dough rises, the raisins move away from each other, not because they're propelling themselves, but because the dough, their universe, is expanding. This is exactly what's happening with galaxies in our universe. They're not jetting away from each other, rather, the space between them is expanding. This concept of an expanding universe was first proposed in the early 20th century, and since then, it's been supported by a multitude of observations. From the redshift of distant galaxies to the cosmic microwave background radiation, all signs point to a universe that's not just expanding, but expanding at an ever-increasing rate. But what could be causing this acceleration? Enter dark energy. This mysterious force, which makes up about 70% of the universe, is believed to be the oomph behind the universe's rapid expansion. Though we don't know much about it, what we do know is that it's incredibly powerful, overcoming the gravitational pull of galaxies to push the universe apart faster and faster. You might be wondering, how can we be so sure of this? Well, the evidence comes from observations of supernovae in distant galaxies. These exploding stars serve as cosmic candles, allowing us to measure distances in the universe. And what we've found is that these supernovae are further away than they should be if the universe was just coasting along. This indicates that something is stepping on the cosmic gas pedal, and that something is dark energy. So, it's as if our cosmic bubble is growing. But don't worry, this doesn't mean we're going to end up floating in a vast empty void. The galaxies within our local group are gravitationally bound and won't be swept away by the expansion. Yet, it does make us wonder, if our universe is expanding, just how big is it really? It's as if our cosmic bubble is growing. But what is causing this expansion? As we look out, distant galaxies seem to speed away faster than light. How can that be, you may ask? It's all down to the difference between cosmological redshift and the Doppler effect. In everyday life, we're familiar with the Doppler effect. Think of a train passing by with its whistle blowing. As it approaches, the pitch sounds higher, and as it recedes, the pitch drops. That's the Doppler effect in action. The same principle applies to light. When a light source moves towards us, its light appears bluer, and when it moves away, it appears redder. But here's the twist. The redshift we observe in distant galaxies isn't due to them physically moving away from us. Instead, it's the result of space-time itself stretching, a phenomenon known as cosmological redshift. As the universe expands, the very fabric of space-time stretches, and so does the light traveling through it. This stretching lengthens the light waves, making them appear redder. Now, here's where things get really mind-boggling. As the universe expands, distant galaxies recede from us faster and faster. Some are even receding so fast that their light hasn't had a chance to reach us yet. This light, from beyond the Hubble sphere, is still on its way. It's like a cosmic message in a bottle, tossed into the ocean of space-time, still bobbing its way towards us. So, when we look at these distant galaxies receding seemingly faster than light, it's not that they're breaking cosmic speed limits, rather, they're riding the wave of an ever-stretching universe. And because of this stretching, there are parts of the universe so far away that their light hasn't had a chance to reach us yet. So, there's light out there we can't see yet. Does this mean the universe is bigger than we thought? Well, stick around, and we'll delve deeper into this cosmic conundrum in the next scene. Prepare to have your mind blown. The actual universe is much bigger than the observable one. Let's dive into this cosmic conundrum, shall we? First, let's talk about the size of the universe. Astronomers estimate the size based on a concept called inflationary cosmology. Picture the universe in its infancy, a mere speck of high-energy density, which then, in a blink of an eye, expanded exponentially due to a mysterious force known as inflation. If we extrapolate this early expansion to today, the universe's actual size could be at least a staggering 10 to the power of 23 times larger than the observable universe. Yes, you heard that right. But what lies beyond our cosmic horizons? Welcome to the realm of the unobservable universe. This is the part of the universe that remains hidden from us, forever shrouded by the limits of light travel time. It could contain more galaxies, stars, planets, perhaps even life forms mirroring or even surpassing the complexity and diversity of our observable universe. It's an exhilarating thought, isn't it? Now here's a question that's been tickling the minds of cosmologists. Is the universe infinite? If the universe is indeed infinite, it implies that our cosmic drama is playing out in an infinite number of places. However, the concept of infinity is a slippery slope, and the scientific community remains divided. Some suggest the universe is finite but unbounded, like the surface of a sphere, looping back on itself. Others argue for a flat, infinite universe. The truth, we simply don't know yet. In the end, the precise shape and extent of the universe remain among the greatest mysteries in cosmology. As we continue to explore, pushing the boundaries of our knowledge and perception, we are constantly reminded of our humble place in the grand cosmic play. It's a humbling thought, isn't it? Our observable universe is just a tiny speck in the grand scheme of things. So where do we go from here? What does this all mean for our understanding of the universe and our place in it? Our journey into the cosmos is far from over. In fact, it's only just begun. As our technology evolves, so too does our capacity to explore the universe. Advanced telescopes of the future, far more powerful than anything we currently possess, hold the promise of revealing distant galaxies and celestial bodies currently beyond our sight. We might even be able to peer beyond the visible light barrier, further expanding our cosmic bubble. And then there's gravitational wave astronomy, an exciting frontier that could revolutionize our understanding of the universe. Imagine being able to detect ripples in the fabric of space-time, caused by astoundingly massive events like the collision of black holes. This could give us an entirely new way to observe and study the universe, one that doesn't rely on light at all. Our earliest glimpse of the universe, the cosmic microwave background, is like a baby photo of the cosmos. It shows us the universe when it was just 380,000 years old, a blink of an eye in cosmic terms. But even this is not the beginning. There are layers of the universe's history, epochs of time, that remain hidden from us, and who knows what secrets they might hold. The enormity of the universe and the complexity of its workings can make us feel small and insignificant. But, isn't it remarkable that we, beings on a tiny rock orbiting an average star in a common galaxy, can even begin to comprehend the cosmos? Our curiosity, our thirst for knowledge, our insatiable desire to explore, these are the traits that make us truly cosmic beings. We've come a long way, but there is still so much more to learn, so much more to discover. Our understanding of the universe is like a puzzle, and we've only just found the corner pieces. But, with every new discovery, with every question answered, we add another piece to the picture. As we continue to push the boundaries of our understanding, one thing is certain: the universe will always keep us guessing.